Okay, here is question 4, another one, which is motion down an inclined plane where we've got where we've got friction. Now, how do I know we've got friction? It's because in the question, always look out for slides down a rough inclined plane. Now, this time it's moving down the plane at constant velocity. Now, you've got to remember this. This catches out so many students. But if something moves at constant velocity, you remember that Newton's laws, or Newton's second law, says that F equals ma. A force, if there's a resultant force on an object, it will accelerate. Okay. Now, therefore, if it's moving at constant velocity, it's not accelerating, is it? So if it's not accelerating, there is no resultant force. So because this is moving at constant velocity down this slope, I know that when I resolve the forces on this block, that the resultant force down the slope will be 0. And because the block doesn't move in or out of the plane, the resultant force, when I look at the forces perpendicular to the plane, they will also cancel out, or the resultant force in that direction will also be 0. Okay, so remember that when we're doing this question. Right, so you've got to draw the labelled diagrams of the forces that are acting on the diagram. Well, okay, same old thing. Weight, 5 kilogram block, so it's going to be 5G. There's going to be a reaction force perpendicular to the plane. R, I'm going to call it. There's going to be friction because we're told it's a rough inclined plane. Now, you're going to ask yourself, is the frictional force going to act down this direction, or is the frictional force going to act up in this direction? And if you remember from the last clip, I told you that the frictional force will always act to oppose the motion. Well, if the motion is down, then clearly the frictional force is going to be up in order to oppose it. So we know that the frictional force is going to be up the slope. And we know, because the actual particle is, if the body is either on the point of moving or actually moving, then the frictional force that's produced is the maximum frictional force, and the maximum frictional force is mu r. Okay, this will virtually always be the case in the exams, that you will be putting in the maximum frictional force in your diagram. Okay, but you should be aware that if the body wasn't moving and it wasn't on the point of moving, then mu r wouldn't be the right value. But it would nearly always, I've never seen a case where it hasn't been that. Right, so that's my labelled diagram. I get 1 mark for drawing that diagram. Right, now we're told that the plane is 30 degrees, saying it's 30. We're told calculate the coefficient of friction between the box and the plane, giving your answer to 1 decimal place. Right, well, you can always remember that we're going to have to resolve our forces. The methodology, if you like, for all of these problems is going to be, let's resolve the forces perpendicular to the plane, and let's choose the upward direction, or the direction in which we're moving away from the plane, as positive. So upwards as positive. We're going to resolve the forces in this direction, and we've got to and therefore the only force that we need to worry about is the component of the weight acting into the plane. The weight force, the 5G, has got 2 components, one acting into the plane, 5G cos theta, or cos 30, and it's got a component down the plane, 5G sine 30, down the plane. Okay, 5G sine 30 down the plane. So as far as the direction perpendicular to the plane is concerned, we've got an R force acting away from the plane upwards. We've got a 5g cos 30 force acting into the plane or in the negative direction. 5g cos 30, and we know they're equal to each other, and that's equal to 0 because there's no motion. There's no motion up or down. Okay, so that's the first equation. Now if you look at this, we can solve this for r because we know everything. So let's do that. We get r is 5g cos 30, which equals, and plugging in the calculator, we're going to have 5 times 9.81 times cos 30 degrees. Always check that you're in degrees. Yep. And we end up with 42.47854,606. So we want that 3 significant figures, so it's 42.5. 42.5, and that is in newtons. Right, done. So we've got R. Now we want to look down the plane. Now you can choose downwards or upwards as positive. It's up to you. Okay. I'm going to choose downwards as positive. So I'm going to resolve the forces down the plane. So notice in this diagram I'm putting the arrow down because that's the positive direction. And I know because it moves at constant velocity, these two forces are still equal to each other. If they weren't, it would accelerate down the plane. Okay, so they must be equal to each other. So immediately I can say that the positive force down the plane, 5g sine 30, minus mu r must also equal 0. And just to let the examiner know that I realise that this is because it's and I'll say because travelling at constant velocity. At constant velocity, and therefore no acceleration. No acceleration. Okay, so fine. Now I'm going to, if you look at this, the second equation, I don't know what mu is, and I know g5 sine 30. I know all that. I don't know what mu is, and I wouldn't know what r was except that from equation 1, if I call this equation 1, I do know what r is. I've worked out r. So if I now substitute r into here, I will get that 5g sine 30 minus mu times 42.5 equals 0. And I'll just say sub r from 1. So that's, I'm substituting the value of r from equation 1. Right, so let's just rearrange this to get mu, and so if I take this minus mu times 42.5 over the equal sign, and then divide both sides by 42.5, I'm going to get mu equals 5g sine 30 divided by 42.5, and when I do that on the calculator, just move that up a little bit. When I do that on the calculator, I get 5 times 9.81 times sine 30 degrees divided by 42.5. 42.5 equals, and I get 0.577. Well, it only wants the answer to one decimal place, so that's 0.6. So it's 0.6 to one decimal place. Okay, nice and easy. And also, in this case, we know that mu lies between 0 and 1, so just double check. If you've got an answer of 1.6 or something, you've probably made a little slip in your calculation. It's worth going back and having a quick look. Okay,